Today, this problem is special positions in binary matrix. So, a binary matrix of m cross n size is given. We have to find out the special positions, number of special positions in this matrix. Now, what is a special position? It is means that the special position is if the cell value of that matrix is 1 and other element in the row and column are 0. For example, here the cell value is 1 and all the other elements in the rows are 0 and all the other elements in this column is 0. So we have to count number of such special position. From this question we can easily tell that the main target is to find the cell where the row will have only one once. We need to keep track of this. Also the column will have only one, right? And say for this example, say 1 0 0 0 0 1 1 0 0. Can we keep track of number of ones in each cell, each row and column? Can you keep track? Yes, we just need to use a separate vector, right? So say this is another vector and this one is another vector, right? So for this row, number of ones in this row is 1. Okay, for this row, number of ones in this row is 1. For this row, number of 1 in this row is 1. Okay, now for this column, number of 1 in this column is 2. For this column, number of 1 in this column is 0. Okay, for this column, number of 1 in this column is 1. Okay, now we have say we will call this row vector and column vector. Okay, now we have a row vector and column vector. Let's traverse the matrix again. The matrix was like this: 1 0 0 0 0 1 1 0 0, and we have row vector that says 1 1 1. We have column vector that says 2 0 1, right? Currently you are here, you can see that the cell value is 1. The first condition is satisfied. So the condition is first condition will be matrix of I j should be 1. Second condition, row of I equals to 1. Third condition, column of j should be 1, right? This specific row will have only single 1. This specific column should have only single 1, and the cell value will be 1. Okay, not 0. So let's traverse this matrix. You can say the cell value is 1. Okay, now let's check whether this specific row have only 1 or not. Yes, it is. Let's check for the column. No. So we won't increase the count. Let's traverse this one. It's 0. First condition is not satisfied. It's 0. This one is 0. This one again. We will come here. First condition satisfied. Matrix I comma j is 1. Let's see for the row. Okay, row of I is 1. Second condition also satisfied. Let's check for the third condition. Column, yes, it is also satisfied. Column of j is 1. So we'll increase the count plus. Then we will traverse for here also. In this case it is 1. First condition satisfied. Second condition, row value should be 1. Second condition also satisfied. Third condition, column value with respect to this column will be 1. no, it's not satisfied, it's wrong. So we want to increase the count. This is 0, this is 0. So number of spatial positions in this matrix is 1, right? So what should be the code should look like? Code will be, let's first calculate the value of n. That will be say matrix dot size, and n will be matrix size, and you have to create a vector of names row of size m to keep track each row number of ones in each row. So m, and initialize with 0, and you have to do the same for column also, and initialize this with n. The size will be n, and initialize this with 0, right? Now your first target will be first calculate the number of one in each row. So for this, just do a basic traversal for and r equals to 0 to r less than m r plus plus. So initialize a temporary variable, say x, and traverse is equals to 0, c less than n, c plus plus, and x plus equals to matrix of row and column, right? And finally update this one. It will be column of this will be row of r equals to x, right? Now you have to do the same for column also. Second, number of 1 in each column. You have to do the same traversal again. C equals to 0 to c less than n, c plus plus. Initialize a variable, say x equals to 0, traverse for each row, r equals to 0 to r less than m, r plus plus, and x plus equals to matrix of row and column. And finally update this to the column vector, column of c equals to x, right? Now your third thing is to count the spatial position. Position, that means 3 condition satisfied, right? So make a temporary variable, say name it as in count, traverse the matrix for it, r equals to 0 to r less than m, r plus plus, and for column equals to 0 to column less than n, column plus plus. Now the condition will be if matrix row and column equals to 1, and first condition is satisfied, second condition is row of this value will be 1, and also the third condition is number of ones with respect to this column should be 1. Then you have to do count plus plus. Now you can also, after this you can mention break also. Why? Because if this one is a special position, if say for example this is a matrix, say that means if this one is a special position, that means all other values in the row will be 0 and all other values in the column will be 0. So currently you are here, right? So no need to check for this position, because it will be anyhow 0, so there won't be any special position in this row, right? So you can mention break and finally return count. The question, it is given that the binary matrix is of size m cross n. So let's calculate the size. Now it's mentioned that a position will be called special position if matrix I and j is 1 and all other elements in the row and column will be 0. So the three conditions are first, matrix of I and j will be 1. Second, number of 1 in row ith row will be 1, and third condition is number of 1 in column will be 1. So we need to keep track of number of rows in ith row and number of columns in jth column also. So for that, let's make two vector int row of size m to keep track of number of ones m, and initialize this with 0, and do similar vector int column of n comma 0, right? Now first we have to calculate number of 1 in each row, right? So let's traverse the grid. Int equals to 0 is then in I plus plus int x equals to 0 and c equals to 0, j less than in j plus plus. Okay, so this means number of, you are calculating number of ones with respect to each row, right? And just update this with row I equals to x, and we'll do the same for column also. That means second is calculating number of 1 in each column. So let's traverse with respect to column first. 0 I less than m I plus plus and column of jx. Now third thing is find out the special position. That means 3 condition satisfied, right? So let's traverse. Before that, let's make a count variable, count equals to 0. Let's traverse the grid. For int I equals to 0 less than m, for j equals to 0 less than n, then we have to say if mat of I j equals to 1 and row of I equals to 1 and column of j equals to 1, then just increase the count. That means this is the special position, and finally you can return count, right? Also you can say if this is a special position, no more further column in the same row will be counted as a special position. So you can just simply say break, right? Let's run this one. Okay, let's submit. Perfect.